Howdy, back with video 2 for Chapter 13, Intrusion Detection Systems and Network Security. Let's talk a little bit more about false positives and false negatives. I defined these in the beginning of the last video. Let's be sure we know what we're talking about. In its simplest form, an IDS is just looking at activity. If it's host-based, network-based, whatever, it's matching it against some predefined set of patterns. When it matches an activity to a specific pattern, the IDS cannot know the true intent behind that activity, whether it's benign or hostile, and therefore it can only do how it's been programmed to react. And in most cases, this means generating an alert that must be analyzed by a human being who tries to determine the intent of the traffic. In other words, is this benign? Is this an attack? Is this hostile? What's going on? And the human typically makes a decision. We're talking more and more about AI taking over a lot of this cybersecurity and automatically making decisions. On some decisions, I believe that's possible. Do we want it making all decisions? No, this would be like a whole highway full of autonomous vehicles, and we've seen how well that's worked out lately. So typically it alerts a human that makes a decision based on looking at the data. By the way, this is also the weak link because, either the user's not paying attention or makes a mistake. Anyway, keep in mind that the IDS is looking at patterns. It doesn't have the ability to detect intent. So in some ways, this is an unfair label. It's functioning correctly, it matches the pattern, but from a human standpoint, there's not information the analyst needed to see, so it may not constitute a threat, may not require intervention, okay? So basically, the IDS is doing just that. Hey, I think I found something. Do you want to look at it? Okay. You make the decision, human being. But it's limited by its signature set. It can only match an activity for which it's stored patterns, or for which it knows that there's a baseline of good behavior, and it deviates from that. So in network-based IDSs, came about after host-based, okay, good little historical fact, and it integrated very well with the concept of perimeter security, okay? So the network-based IDS, when you run host-based systems for a while, that was a lot of overhead. That was a lot of putting it on the PC, putting it on the server, looking for things there. So the host-based systems weren't centrally managed. There was no way to correlate alerts between the system. So you've got an enterprise, let's say, and you've got 100 different laptops or desktops and servers. And at the host-based system, you have alerts coming, but they're not all the same. They're not all the same time, the like. It was hard to correlate them. So basically, this grew into the need for a better way to get network IDS. So the amount of malicious activity comes across the network, right? It doesn't just get to the PC by magic, right? It comes across the network. So this new breed of IDS that came about focused on the source of a great deal of the malicious traffic, which was the network itself. Oh yes, network perimeters are a little like castles, firewalls, and network intrusion detections from the gates and guards to keep the malicious traffic out. Okay. Kind of like my analogy, but I'm always talking about a house. Obviously, somebody's got visions of grandeur here. Although I would put the intrusion detection systems within the firewalls, within the network itself. So since it focuses on network traffic, it's got to examine it as it passes it. It's got to analyze it. Now let's think about all this. It's protocol, its type, its amount, its source, its destination. Hey, here's how you understand what I'm telling you. That is the protocol. Hey, here's the source IP address. Here's your destination. Here's the content. Here's the traffic already seen. Many other factors. So the analysis must happen quickly. You can't have a big, complicated, large overhead. And the network intrusion detection must be able to handle traffic at whatever speed the network operates to be effective. So they're typically deployed so they can monitor traffic in and out of an organization's major links. And they look for certain activities that typify hostile actions. Is something scanning ports? Is it look like a denial of service attack? Is there malicious content in the data payload of the packet? Looks for vulnerabilities, Trojans, viruses, tunneling, brute force, whatever. But it's looking for certain activities that typify hostile actions or misuse because we are looking for something with the intent. And in general, most of them operate in a fairly similar pattern. This shows the logical layout of an IDS. Consider this a function and activity. Remember, this isn't a hardware thing. Network traffic, the traffic's collected, it's gone to an analyzer that compares it to the signature. It has the alarms, it alerts the user, stores the reports. So the major traffic components include the traffic collector, the analysis engine, reports, and the user interface. And the signature database is usually much larger than that for a host-based system. And think about this, why is that? Well, because the host-based system is looking for certain things that are going right in that system and everything's going to be there. The network has to be concerned about things being distributed over the network, things being delayed. It's just more complicated because it's looking at a number of hosts. So the traffic collector is designed to put the traffic for the network, and it behaves in much the same way as a network traffic sniffer. It pulls every packet to see if it's, pulls it off the network. It attaches itself to a network interface card, instructs the network interface card to accept every packet it can. They accept and process every packet regardless of the practice range and destination. It's one interface. The analysis engine serves the same function as a host-based counterpart with some substantial differences. All this stuff, what I want you to know is basically, what are the major components? Collects the traffic, it analyzes the traffic, it reports, and there's a user interface because we have human interaction responding. What is a signature base? How does the database work? Which is larger? Why is it larger? And then this last point, using lessons learned from this, they modify the logical component designed to distribute the user interface and reporting functions. And basically, there was a need to handle multiple links in many different locations. So this was solved by dividing the components and assigning them to separate entities. So you have the traffic collector, the analysis engine, the signature database is typically one single entity called a sensor. And the sensors we report to and be controlled by a central system or master console. So you have the sensors collecting the data and rolling it up to a master console. So here's your distributed network for IDS. On the left is what we've talked about. On the right then, consolidated the alarms and provide the user interface and reporting functions that allowed users in one location to manage, maintain, and monitor sensors deployed in a variety of remote locations. So by creating separate components, these were able to build a more capable and flexible system. So with firewalls present, location of the NIDs relative to the firewall had to be considered. With encrypted communications, network systems could be placed both local and remote perimeters and still be monitored and managed securely from a central location. So this distributed network type of architecture for IDSs is a bit more complicated, is more effective, although there is an issue that the security personnel, because the sensors obviously have to have visibility of the network traffic in order to analyze it, and that itself can be problematic. Okay, so let's see how this goes. Here's a NID sister placed in front of the firewall. Okay, where do we put the NID sensor? I told you I always think of them inside. They can be outside. And it starts looking at your network traffic coming in. And it sees all the traffic coming in, and including attacks against the firewall itself. And this includes traffic that the firewall stops and does not permit in the corporate network. And when you put the sensor in this manner, it's going to generate a large number of alarms, including alarms for traffic that the firewall would stop. So this tends to overwhelm the human operators managing the system. Now let's go back and remember what a NID sensor is. NID sensor is going to be the collector. Where was that slide? The collector, the analysis, the signature database, everything but the reports and human interface. So we put it outside. What's the disadvantages? You're going to be collecting a lot of data. You're going to get a lot of false positives. You're going to be capturing things that the firewall would have caught anyway. What happens if you put it inside? Well, it sees and analyzes the traffic that's being passed through the firewall. So it had to have made it through the firewall and into this. This doesn't allow it to see attacks against the firewall. So it generally results in fewer alarms, and it's most popular, and that's my analogy of it being within the gate, the fence, is because this is the most popular way to do it. So NIDS examines the network traffic for suspicious or malicious activity, does a port scan, 2 examples. It's a reconnaissance activity. A potential attacker wants to find information about the systems he wants to attack, so he just, because software ports, can be just incremented by 1. He just goes through and does a dumb kind of scan against it, or does a scan against hardware ports. The ping of death. Certain operating systems could be crashed by sending a very large internet control message protocol echo request. So this was 2 examples of what the network intrusion detection system is trying to detect. So the advantages: it provides good coverage with fewer systems. It can be deployed, maintained, and upgraded, usually at a lower cost. It has visibility into all network traffic and can correlate attacks among multiple systems. Very important point. The host-based system could not do this. Okay? Disadvantage: it can be ineffective when the traffic is encrypted. It is ineffective. Can't figure out what's in that encryption. It cannot see traffic that it doesn't cross, right? It must be able to handle high volumes of traffic quickly. It can't slow the network down, and it does not know what activity is on the hosts themselves. So there are 2 types of NIDS, active and passive. The passive simply watches the traffic, analyzes it, generates alarms, doesn't interact. It doesn't modify the defensive posture. The active, as you would guess, it contains the same components, but it can react to the traffic. And how does it react to the traffic? It can do anything by sending a TCP reset message, interrupt a potential task, disconnect a session, dynamically modify firewall rules to reject all traffic from specific sources, which would be pretty cool, right? For the next 24 hours. So the active can do anything it needs to further detect and protect. So we've talked about snort. We're going to forget suricata. And that's going to end video 2. I will see you in video 3. Thank you.